The SEM images here in figure 5a showed that the spherical particles loaded on the surface of the original FSO1 became larger after absorption, and the morphology of the zeolite framework of copper at FSO1 hardly changed. TEM images can further reveal the current form of particles on the surface and interior of copper at FSO1. In figure 5b, the diameter of the black particles is about 50 to 200 nanometers, which is mostly consistent with the SEM observation. As illustrated in the XRD spectra of copper at FSO1 before and after absorption in figure 5c, several distinct characteristic peaks assigned to copper iodine were found. There is no doubt that the metal copper has a chemical reaction with iodine. For the copper at FSO1 iodine, the TGA graph in figure 5e revealed a significant weight loss in the range of 70 to 200 degrees Celsius. Since the pristine copper at FSO1 was stable under this condition, the weight loss should be primarily due to the release of physically absorbed iodine by the iodine-loaded copper at FSO1 during heating. As shown in figure 5f, in the full XPS spectra after the capture of iodine, a new peak emerges at the binding energy of 610 to 635 electrovolts, indicating that iodine is absorbed on the sample. These results confirmed that the copper and nanoparticles in the support reacted with iodine to form copper iodide, thereby firmly immobilizing the iodine through strong chemical interaction. The optimized structure of copper at FSO1 iodine is shown in figure 6, and the corresponding calculated absorption energy value was about negative 6.2 electrovolts. The formed copper iodide promoted copper atoms closer to oxygen atoms in the zeolite skeleton, showing that the zeolite has a greater affinity for copper, as well as stably immobilized iodine. The copper atom in the copper FSO1 support was a main active site for charge transfer with I2, or iodine, as shown in figure 6c, which was consistent with the XRD and XPS analysis results. To further understand the interaction between absorbed iodine molecules and parent FSO1, a DFT calculation was used to obtain energy absorption equals negative 0.476 electrovolts, corresponding to the weak absorption in figure 6d. Briefly, this fully reflected the superiority of combining the carrier with the active site.